Hello, and welcome to Chapter 4, Section 4, Trig Functions of Any Angle. So this section, we're going to construct and compare linear and quadratic and exponential models to solve problems. And our essential questions are: what sorts of functions can we construct with Pythagorean identity, and how can we use a reference angle? So, if theta is any angle in standard position, so you have P equals x, y, that's a point on your terminal side of theta. So R equals the square root of x squared plus y squared. If you think, that's kind of like the Pythagorean theorem, where C equals a squared plus b squared. It's the same thing. So your x, y is your distance from 0, 0. So your trig functions of theta are defined as the following ratios. So sine theta is y over r, cosine is x over r, tangent is y over x, and then your reciprocals are your other functions. So r over y, r over x, x over y. But x cannot equal 0 if you have x or y in your denominator. I would write these down, they are important and they come up a lot. So let's look at this first example. It says P equals 1, 3. So x equals 1 and y equals negative 3. I'm sorry, P negative 3. So this means we need to solve for r. So r is going to equal 1 squared plus negative 3 squared. So r is your square root 10. Now we can solve. So you know y is negative 3 and r is square root 10. We can't leave it in this form because of our rule where you have to multiply both your numerator and denominator by your denominator. So negative 3 square root 10, 10. You do the same thing with cosine. So this time you use x in your numerator, so you have 1, and then over square root 10. Again, you can't have a radical in the denominator. So all I'm doing here, you found your radius, or your r, which is your hypotenuse. That's your denominator, and then you take y from whatever your points are. So we're going to look at the other examples of this. So we know r is square root 10. We found sine and cosine. So pause the video and try and solve for tangent, cosecant, secant, and cotangent. You're going to do the same thing. Your point is still 1, 3, so x still equals 1, y equals negative 3. So pause your video and see if you can solve this one on your own. Alright, so the answers are up on the board. So tangent of theta is negative 3. Cosecant is square root 10 over negative 3. Secant is square root 10. And then cotangent is negative 1/3. And that's it. So that's all you have to do for those ones. So it says, evaluate if possible the cosine function and the cosecant function at the following quadrantal angle. So your theta is 0 degrees, so it's at 0. So this means your P is 1, 0. So x is 1, y is 0. So let's see if we can solve them. So you have x is 1. Do you know what r is right now? R is just this, so it says r equals 1. And that's it. So for your cosecant, you have your r, which is 1, and y is 0. Are you allowed to have 0 in your denominator? Nope. So it's undefined. It's undefined because you have a 0 in your denominator, and you're not allowed to have 0 in your denominator. So we're going to look at another two. In this case, theta is 90 degrees. So your point is 0, 1, and your radius again, or your r, sorry, I keep calling it radius, your r is 1. So cosine, you have x, which is 0, r is 1. 0 over 1 is just 0, so you are allowed to have that one. And then your cosecant, your r is 1, and your y is 1. So your answer is just 1. So I'm going to have you try this one on your own. It says theta is 180 degrees, or pi. So your point is -1, 0. So x is -1, y is 0, and your r is still 1. So pause the video and try this one on your own. Alright, so you should have had cosine theta is -1, and cosecant theta is undefined because you have 0 in your denominator again. So there's one more set we're going to try. It's going to be at theta equals 270. So again, pause the video and try this one on your own. You should have gotten cosine theta equals 0 and cosecant theta equals -1. So you're just plugging in your points. So whatever x is, you plug that in. Whatever r is, you plug it in, and you simplify or solve. So each quadrant, just as you have with x and y, each quadrant you have positive and negative signs of your trig function. So in quadrant 1, all of your functions are positive. In quadrant 2, sine and cosecant are positive. Quadrant 3, tangent and cotangent are positive, and then quadrant 4, cosine and secant are positive. So I would take a snippet, write this down, something so you can always see it. It is very helpful. We're going to look at a couple examples. So if sine is less than 0 and cosine is less than 0, name the quadrant in which your angle lies. So it can't be quadrant 1 because everything is positive. In quadrant 2, sine is positive. In quadrant 3, tangent and cotangent are positive, so this is a possibility. And then quadrant 4, cosine and secant, so it can't be this one, so it lies in quadrant 3. So you have to go through and check to make sure that it can't be positive in each of those. Since it has 2 of them, you want to make sure that each of them is satisfied. So if you're given tangent theta equals -1/3 and your cosine is less than 0, find the sine and secant. So because both tangent and cosine are negative, theta lies in which quadrant? So you want tangent and cosine to be negative. Everything's positive in 1. Sine and cosecant are positive in 2. So which ones are negative? So it lies in quadrant 2. Because both your tangent and cosine would be negative. So tangent theta is y over x, so that means you have 1 over -3, so you have the point -3, 1. You want to find your r. This is just your rule that we talked about in the beginning of this video. So now I'm just plugging in the values that I already have. So all I did was just plug in the values that I already had from up here, and then this was R. And that's all you have to do. So don't forget to complete the questions below, and then watch the next video. Next time we're going to talk about reference angles.